All right, yesterday I wasn't able to get through the whole thing, so I'm going to kind of back up to yesterday's slides, make sure I cover all those, and then we'll go on to today's. And we're covering the important object-oriented facility of inheritance. And the idea is that you have like a base class, and you have subclasses that increasingly focus in on the specifics of it. And the why of this will kind of emerge. I mean, if you're like me and like many who come from a more procedural orientation, really an important question that you're probably thinking is, okay, why do all this? Who cares? You know, what is the benefit? And for that, it's just kind of hold on. And so just temporarily, you know, is not so much pressing the I believe button, but for now, you know, just kind of recognize that those are legitimate objections. There are situations in which a procedural orientation is a more appropriate framework for doing things. And the thing is a lot of the principles of procedural programming are still present here. It's just they're present in a different context. So for example, an important part of procedural programming is the idea of calling functions to do certain things. And within those functions, there's a lot of logic and, you know, just sort of basic block and tackling kind of programming, you know, about, you know, control structures and logic and expressions and all that kind of stuff. And that's still here. It's been kind of tucked into these methods. The first big picture is what we've already been dealing with, which is objects sending messages to each other. And that example with the snakes and ladders game, you know, as sort of silly as it might be, is a nice illustration of that, because there you had objects that were sending messages to each other. I mean, that's and what happens is in an object-oriented program, things are less linear. Like when you're sending messages to each other, and then it doesn't become starting at the top of the code and kind of just going line by line. That goes on within the methods. Within every method, you start at the top of the method, you go to the end of the method, but then when you return from the method, you know, things just kind of start going in a non-linear fashion. And that's one of the challenges. So now that's sort of big idea one. This is big idea two, and this relates to this polymorphism or software reuse. I mean, which was kind of less important as the idea of, for me, this principle of ignorance and apathy. That is, when you're sending a message to another object, you can kind of not know or care how exactly it's performing its job. You know, in other words, it's a step back from micromanaging. In other words, the idea is if I send a message, another way of framing that is I have an object and I'm giving it a task to do, and how it does that task is I don't really care about as long as that task gets done. So inheritance, this subclassing, you know, having parent class, superclass, child class, all that, that's a of implementing this polymorphism idea. It's not the only way, but it is one of the primary ways. And when it was introduced, like again, people kind of went crazy with it and tended to overuse it. And so there was a little bit of blowback on it, and pushback and whatever. And nevertheless, when things kind of settled down and it wasn't a big hype anymore, it is still a very important and valid way of implementing this in proper measure. Let's just put it that way. Okay, so now, so what can we do with it? Is that we can define common common properties of every object. That's one of the benefits. It's, in other words, if I have a lot of different types of objects I have running around, and maybe the exemplar is this idea of these shapes. So I have all these shapes running around. They could be circles, squares, rectangles, whatever. And in the context of, what am I going to do with these shapes? Maybe I'm going to have a drawing program, or maybe I'm going to display them, or whatever. So that's less important. Is the fact that somewhere I'm going to have these shapes, and there are things I want to do with those shapes. And so, when you're designing these things, you think of, okay, I have all these different types of things I want to represent, but what are the things that they all have in common? And the things that they all have in common, I want to put in a base class. What is the advantage of that? Because if they are in the base, all these common things are in the base class, I put it in the base class, and then I validate that piece of it at least is working, then I don't have to validate that piece for each of the subclasses. In other words, I just have to do it one place. Without inheritance, if I have to do the same thing in 10 different classes, I have to validate it 10 different ways. Whereas if that's a thing that's common to all of them, and I just have it in one class, and then everybody inherits from that, if I validate it one time, and then everybody else gets it for free. So we can take those common things and then narrow it down to the specifics. So, for example, so here one example is we talked about these. They had these different types of clocks. Okay, so here's an example. The idea here, if we're representing this in code, and I don't think we will be doing that, but if we were, then everything common to a clock, as we're interested in, we would put right up here. Now, in this particular case, one of the things that we'd be most interested in is, why have a clock? Well, tell me what time it is. So there we would use an abstract method. We'll touch on that later. And so the other thing is that defining an abstract method up here means that we can say that every clock is going to be able to have this message passed to them, but we're not going to say exactly how they're going to do it until we get down to the specifics. And again, that's the ignorance and apathy thing. So like show time, in this case, just as an example, I mean, if this were a display type of thing, then the analog clock would show like a little dial, and the digital clock would show the numbers. Evidently, kids these days don't know what the heck this thing is, and so they anyway. But that's so here now. This is an example that I kind of used with another book, but this is just sort of a little more simple one. So in this particular one, I have an abstract class called, I'm going to call it a shape, just like the other, and the instance variables are going to be a base and a height. So every shape is going to have in other words, sort of a width and a height. And so when I create one of these shapes, with this one, I'm going to give it these two values, and some of the common ones are going to be, say, I'm going to erase it. I have setters and getters for the width and height, and then these are because they're kind of in italics, that indicates abstract. So shape, shape is in italics. That indicates that it's an abstract class. The draw and the get area methods are also in italics, which indicates that they're abstract. So what does that mean? That means that every shape has a draw method and has an area method. So you can tell me what, to draw it, and you can tell me what the area is. But if I want to get the area of a circle, I'm going to need to do it differently than the area of a square or the area of a triangle. Why? Because the formulas are all different. So what this allows me to do is saying that if I have something that all I know about it is it's a shape and I say go draw it, then if it's a circle, it's going to draw it as a circle. If it's a square, it's going to draw it as a square. If it's a triangle, it's going to draw it as a triangle. If I say, give me the area, then it will give me whatever its area is based upon different equations. And so this is a concrete example. Now the one the book does has a little bit of a different structure, and so we'll be kind of implementing that a little bit more. But the idea is that what we can define now. This gets back to strongly typed. So how do we refer to these things? Through object references. So every object reference has to have a type. What is that type? The type up till now, it's been, it would be either a class or an enum. Those are the two that we've seen. So I can declare a variable to be any one of these. I can declare a variable to be a shape, or I could declare a variable to be a circle. So why do it one or the other? If I declare an area to be a shape, I can declare it to be a shape, but because it's abstract, I can't instantiate it. Now, in order to actually send a message to an object, there needs to be an actual object there. And so the only objects in our models are going to be concrete based on concrete classes. So there will not be a shape object. There will be a shape reference variable, but the actual object in this case will be either a circle, a square, or a triangle. Now this is where things get a little tricky. So okay, now why do it that way? Well, supposing I want to define, so let's say these are the only three possibilities, and let's envision a drawing program somewhere. And somewhere, so how would this program draw its stuff? Well, I need to invoke draw on every one of these things so that they display themselves. So how is that? There'll be an object that kind of holds all these things, and then when it's time, it'll say, okay, I want to draw all these guys. So how can I define that if I don't have this? If all I have are these individual classes? Well, using what we have available, I could have an array of circles and an array of squares and an array of triangles. And so to display them, I would have to do a for loop on all the circles. So you circle, draw, 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 draw. Squares, draw, 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 draw. Triangles, draw, draw, draw. And now, okay, so that would work, but it's like I got to do that 3 times. Now, what if I say, well, I want to have ovals now? Well, if I want to add ovals, then all of a sudden I need to have another array of ovals and kind of go through that. So for every new type of shape that I add, if I do it that way, then I have to do some more stuff. Now instead, imagine that I just have an array declared to be shapes. Now I can declare a variable to be of type shape and instantiate it with any one of these 3. And so the logic would be I just have an array of shapes, and I'd go on a for loop through all the shapes and say, each of you draw, 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 draw. And they all know how to do it because they've subclassed the shape. By making it concrete, they have had to implement all the abstract methods, including the draw. And they know how to draw themselves. So a circle is going to hopefully draw it like a circle, a square is going to draw it like a square. Now if I want to add an oval, all I need to do is subclass shape again, make sure that all of its stuff is working, and then throw it in. I don't have to change that array. It's just, because it's a shape, I can just sort of bang it into the array. So that, you know, does that make sense? Am I, yeah.
So, no, that makes sense. So if I wanted to draw the shapes, let's say I didn't want to do a triangle, you just put a check in there, if it's a triangle, it'll draw it.
Say that again.
So I'm trying to draw all the shapes, so
Right.
circles, squares, but now you said I want to draw the circles and the squares, but I don't want to draw the triangle. How would you just put a check in there to see if it's a type triangle, if it's not apply it?
Well, what I would do is I would add another variable, say like a Boolean, call it visible, and then on each of, you know, when I'm going through, I would say something like, if visible, draw. And then if there's some I didn't want to draw, I would set that visible to false. And then that's the way that's a way to do it.
That variable would be for, then you have to change that in your code that defines the triangle, right? Not necessarily in your instantiation of the particular triangle.
Well, you could, I would set it to be true when I was instantiating it, and I would have like a setter, and you know, and then now when you know, I would need some mechanism to cause that to be set to false or whatever, you know, maybe like if it was being displayed, I could maybe sort of select it somewhere and say, and then have a checkbox that say, okay, make it invisible or something. But and if that was an issue, I mean, I would actually define that up in shape so that every shape would then have the ability to say, am I visible or not? And that's a great example of this kind of thing. In other words, I'd have two choices. I could set visible for each one of these separately, or if I define it up in shape, and in fact I define it in shape, have a setter getter up there, then I don't have to do anything more for each of these guys. Okay, so now, this was something that Java, when it came out, back when dinosaurs ruled the world, other object-oriented languages, especially C++, did not have a common ancestor. In other words, there was no granddaddy, and it turns out that there are, what Java realized, the Java developers realized was, and this was largely through experience with other object-oriented languages and realizing some of the issues that came up, is that they wanted to make sure that there were things common to every single object. That is, every object that got created, they wanted these common things. And so they used this idea of inheritance and the idea of this sort of granddaddy class. Now it's a little confusing because it's a class called object. And so it's actually possible to instantiate an object of type object. That's entirely possible. And what that enables is that every, you know, there are a bunch of things, some of which it turned out were not such great ideas, but these are three of the things that every object has. And we've been actually using a lot of this toString thing. So when you go to print an object, you say print this object, what it does is invokes the toString method of that object. And that is guaranteed to be there. In other words, what would happen if you didn't have this? And this is what they ran into in C++ a lot. This is a nice thing to have. So what would happen, though, if you didn't have this? What would happen if you try to invoke a method on an object that doesn't exist? Well, the compiler won't let it through, because the compiler will not allow you to invoke a method, to have code that invokes a method that it can't guarantee will actually be there. Because the toString exists in object, and every class in your Java program is a subclass of object. Every class has a toString method. So when I go to print it, it will always be able to print something. Now the something is this gobbledygook that you've probably seen. It's actually the name of the class, an @ sign, and some gobbledygook. The book, I think, claims that gobbledygook has something to do with its location in memory. That's actually not true, because the Java virtual machine has no connection from the user standpoint to the memory of the machine. So it's just an arbitrary number. It's just some gobbledygook. Okay, so now what we've already seen is that we can override methods. And so the subclass, you have everything in your ancestor class. And so we can override a method. We've been doing that with the toString method. Everybody has a toString, and the default is this, thing, uninformative string. But say if we have like a playing card and we want to display which suit and value it is, then we override the toString, and that means that when, so let's say this is our playing card, and this is how methods get invoked by the virtual machine in this context. So let's say this class does not override toString. So when it comes to, the compiler has allowed it through because when I've invoked the toString on an instance of this, it was guaranteed to be there. Now when it goes to invoke it, what it does is say, okay, I want to invoke toString of this object. And it looks in the class and it either finds it or doesn't find it. If it doesn't find it, it looks for it in the superclass. And if it doesn't find it in its superclass, it looks for it in the superclass all the way up to object. And it is guaranteed to find it because the compiler has let it through. In other words, the compiler has verified that somewhere in the class hierarchy this method exists. In the case of string does override toString. And what it does is instead of printing the gobbledygook, it prints actually the actual characters that comprise that string. So that's overriding. So in the context of the shapes, draw was defined in shape so that if we had if I call on something that's been declared to be a shape but is one of these guys, it will be implemented differently. So in that case, it was overridden. And when a method such as draw, in this case, is declared to be abstract, then it must be overridden in order to have a concrete class. In other words, if a class has one abstract method, then it must be declared abstract. There's no other choice. You can actually declare a class to be abstract even if it doesn't have any, but that's, the main use case for an abstract class is that I have a partial implementation and other stuff that I don't want to implement yet. So in particular, for our shape, there are lots of, so I can implement the base and the height because every shape is going to have one of those, but I can't implement the draw or the area because that's going to be different for each individual one. So I have a partial implementation, and then the rest has to be subclassed. Okay, so all right, abstract classes, and we'll see how to define them. We're going to touch on protected visibility. It's something that's going to be more important next quarter, actually. And then the other is the constructor calling sequence, which is kind of which I've kind of touched on earlier in a previous class, but it bears repeating. Okay, so abstract classes. Now, An abstract class is one that you can't instantiate. You say, well, what the heck? You know, why are you defining things that you can't instantiate? So hopefully it's becoming a little clearer. So the shape class was abstract because it doesn't make sense to have an instance of shape. In other words, shape is kind of an abstract concept that is implemented by different specific shapes. So if I tell you, okay, I have this thing, and it's kind of take it out of the context of this. Just say, okay, I got this thing, and it's a shape. And you say, well, what is its shape? Is it a square, a rectangle? Is it kind of some weird thing? Okay, I got this thing and it's a shape. Well, what is its shape? Well, okay, this is the shape of the thing. But if I just say I got a shape, you have no idea what the heck it looks like. So the shape is, even putting aside from the programming context, shape is an abstract concept that is, instantiated or implemented by a particular shape, regardless of what that is. So why do this? Because in the context of a situation where we have many different types of things, this is a shape, this is a shape, this is a shape. They're all different shapes, and if I want to represent each of these, I can represent them all as a shape, but if I want to consider the instance of this, that is, what is the color of the mouse, then I need to kind of look at the characteristics of the specific thing. So we can, if we extend extend or subclass an abstract class, and it's not abstract, then it's a concrete implementation, and that's something we can instantiate. So here's kind of expand. This is kind of the books one, and it uses the same kind of convention. So italics ones are going to be abstract, and the non-italic are going to be concrete. So shape is abstract, and then they say, okay, they divide it into one-dimensional shape and two-dimensional shapes. A little bit of a misnomer. What they mean, they're all two-dimensional shapes, but what they mean is that a circle really only has one value. So with a circle, I can define a circle. Well, first its location, but it just has the radius. And likewise, a square, since all the sides are equal, I just need to give it one number. Whereas an oval, I need to give it two numbers, and likewise a rectangle, I need to give it both the width and the height. So that's how the book has kind of broken this down. Perfectly reasonable. So what it's done is it said, well, if I have a one-dimensional shape and two-dimensional shapes, these are still abstract, and they're just kind of honing in on it a little more, but these are all concrete. So I can declare a variable to be a shape, or a one-dimensional shape, or a two-dimensional shape, or I can declare things to be each of these concrete classes. So those are my choices. Okay, when do you do which one? Well, in a context where I'm going to have a bunch of different one-dimensional shapes only, then I would declare it as a one-dimensional shape. If I know they're all going to be two-dimensional shapes, I would declare it that way. If I'm going to have a mixture, I would declare it up here. The principle is that variables are ideally declared in the most abstract, the most abstract type that you can actually use. So how do we actually do it? Well, there's a keyword abstract. So I would declare shape to be public abstract class shape. And similarly, public abstract class. Now, how do I indicate that I'm subclassing? I use the extends keyword. So one-dimensional shape would be public abstract class one-dimensional shape extends shape. And two-dimensional would extends shape. Now, the thing to understand here is that I can only extend one class. I can't extend more than one. I can, if I, I can only I only have one direct parent. I can't have multiple ones. And that's something that's different from C++ allowed multiple ones. So like in C++, I could have it be, this was kind of before your time, but there was a Saturday Night Live ad for a product that was a dessert topping and a floor wax. So, so what happened was, through experience, it turned out that if you extend two different classes, that just led to problems. So Java said only one. Yeah.
So, say we have, in the triangle class, we have subtriangles, there are different types of triangles. You could still do the extend, and then you just, instead of one-dimensional shape, you could do a triangle. Let's say we have like, whatever, isosceles triangle as a subclass within the triangle.
Exactly. Yeah.
Okay.
Yeah. Good point. Yeah. So if I subclass triangle, I might want to subclass it further, like right triangle, isosceles triangle, equilateral, et cetera. Yeah. And a lot depends on the context. If those are things that are useful, I can still extend these if I want.
But it would break it if you tried to do isosceles triangle.
Let's see. No, a triangle would have to be a two-dimensional shape because I need a base and a height.
Right.
So I would need two. So they would all be on this side of things. I wouldn't kind of do things this way, but nevertheless, it's a good example. Why? Because sometimes you'll be in a situation where you're dealing with some legacy code that somebody else has created. So in this particular case, if I'm dealing, this isn't how I would design it. But if I'm stuck with this, then you deal with it as best you can. And it's not that this is a terrible thing. I mean, it's not awful. It's just I don't really see the utility of it, but maybe if I kind of study it a little more, I will. Okay, so the abstract methods, the way we define them is, well, we actually don't use well, you don't have to use the abstract keyword. What you do, well, or maybe you do. Did I do this with code? But regardless, what you do is you still have the visibility type, the return type, the name, and then and optionally if there's a signature, the signature. But for a concrete method, you would then have your open close curlies and have all the implementation in there. Instead of that, you have just a semicolon. So if a class has one or more abstract methods, you must declare it to be abstract, and you can declare it to be abstract even without them. Want to do is okay, this is our ladders here, so let's do this in another package. I'll call it shapes. So let's now in the book they show how to do it in Eclipse, and Eclipse has little things where you can you have little check boxes and stuff to declare that. NetBeans doesn't have that, so we have to do some of this by hand. So if I want to declare shape as abstract, so there's no there's no place to specify that, so I have to kind of edit it afterwards. I just have to say abstract. Abstract. Okay, so now notice no red squigglies. I'm still okay there. And so what are the common things? Now for whatever reason the book decides to kind of go with a protected business with this. If you have setters and getters, you don't really need that. So I'm going to do this differently. And what it's going to, so what we have is, well, in the book, the book uses kind of the more antiquated point class. It turns out that there's a better one. Why aren't you? There we go. There's the Java AWT point that the book uses, and that, you know, that's well. What happened was Java kind of because Java had a superior object model to what people were kind of used to, and because it just made this kind of development just substantially easier. Java kind of took off. It was overhyped, but like in the mid-90s, everything was kind of going crazy. It went a little more crazy than the people at Sun Systems, which is where it was developed, realized. And so they had this sort of, they needed a crash development in its graphical pieces. And that resulted in a package called Java.AWT, which stands for Abstract Windowing Toolkit. It was developed in kind of record time, and unfortunately it kind of showed it. So we called it the Awful Windowing Toolkit. And we weren't alone in that, but as a result, they kind of came up with better things. So this point 2D is a little better one. So that's, and then now this is where, okay, so the two things common to the shape are going to be its location and its dimensions, and that's kind of where it's going to be representing as sort of the 1 or the 2. That's, so as an abstract class, we still have a constructor, and in this, oops, what did I say? Shape. Okay, do you see what that, well, let me use this bears here. This is where, I mean, the red squiggly of death is actually your friend, because it's telling you what went wrong. So this was a fat finger on my part, but it said, look, invalid method declaration, return type required. And I said, what the heck? I was trying to write the constructor. All right, so if I write the constructor, I don't have a return type. Every other method, I have to have a return type, even if it's void. Okay, so what the heck? You know, okay, that's supposed to be the constructor. I called it square because I was sort of thinking of something else. And so really it has to be the shape. And so for this, now I want to encapsulate my fields here. Where are we here? I want to refactor encapsulate fields. I'll select all of them because I want to be able to set and get everybody. But since I'm only giving it a location, I'm going to sort of set the location. And as somebody, now NetBeans kind of complains about this. This was something, this is a NetBeans thing. And how should I say, it's like, what their concern is that sort of an evil developer could subclass this setter method and do something evil with it. That's what their concern is. Is that a legitimate concern? I mean, who knows? If that's a concern, you can actually make it final, and that makes it go away. Why? So a final method cannot be overridden. So this says when I set the location, I can just sort of set the location period, and this is the only place it's going to get done. So I mean, I think they're being overly worried here. But then on top of this, I have some abstract, remind me of the abstract methods here. let me find it here. Oops, was the other one. No, it was something else. Okay, so before I go on, and this is something the book. I don't mean to knock the book too. The book by and large is pretty good, but there are some places where it kind of, to me, doesn't quite. These are just things that I'm. All right. Do you see this call here? The generated one for arrays is an encapsulation violation. Why? Because it's returning the actual object reference to these dimensions, and that means that it's. It's not that there's going to be sort of an evil thing about that, but it would be too easy to, if somebody, another object calls this, sets those values to something, now all of a sudden you are changing the internal data of an object from outside that object without going through a method. And the encapsulation prime directive is that all changes to your data have to be through a method of that object. That's the only way. And this violates that. But there's an easy fix, and that's the clone. So if I simply return a clone of my array, then they can do whatever the heck they want with it, and I'm safe. Likewise, the setter. So if they set, somebody outside this has instantiated this array and then passed it to me. And if after they've done that, they change that value, they've now changed mine. So again, I can just use the clone. So I have yet to encounter a situation where passing the clone of a setter or a getter for an array is not the right thing to do. Which is not to say that one may exist. I've never encountered it. So when you have an array, and this is something that I'm going to be insisting on, that whenever there's a setter or a getter for an array, then you must use a clone. Just remember that. Okay, so okay, I do need the abstract. So for the draw, and let's see, I think. Okay, this kind of gets into when we're actually drawing things. There's a graphics object that we use, and so we're gonna say, okay, we're gonna draw it and pass the graphics to it. Let's see, what was the other? Did it have a get area? If it didn't. Okay, so now let's, here's how we can, let me do a simple one. My circle, or, that's right, yeah. All right, so let's kind of follow them. Oh, wait, let me show you how to, let's do it again. Okay, so let's do the one-dimensional. Okay, so here for my superclass, I can hit Browse, and then I need to start. Okay, so if I just sort of start typing that superclass, I can select that, and I say OK, and then I finish, and then Okay, so now I get wrote the extends for me, and it gives me a red squiggly. So what's the red squiggly? It says, again, the red squiggly is your friend. What does it say? It says, is not abstract and does not override the abstract method get area. So, what is, in fact, there's the little light bulb here. I have a choice. I can either implement all the abstract methods or I can make it abstract. And so let's make it abstract. Now what is the problem? Constructor shape. So this is that that weird, remember I said when we were talking about super and this constructors, I said there would be a very confusing error. This is an example of it. Okay, so what does it say? Constructor shape in class shape cannot be applied to given types. Required point2d found no arguments. Okay, do you see what happened here?
We need to write a constructor that takes a point2d argument.
Exactly, yeah. So what it's saying is that I didn't define a constructor, so it wrote super with no argument for me in. And super calls the superclass constructor, but the superclass constructor, where is it? Requires a point2d. So what is the solution? I need to write a constructor. One-dimensional shape. Location. I need to fix my imports. So I get that in, and I just pass it to location. Okay, so that was an example of that kind of weird error that kind of showed up. Okay, so that's that kind of does it for today. Again, so tomorrow via Zoom, and